Alright guys, this is the last form of linear functions that you'll see this year. It's called standard form, and we write standard form as ax plus by equals c. So again, this is a much more different way of writing any of our linear functions we've seen so far. So far they've all had y on one side and x on the other. The difference here is x and y are on the same side. These still are the independent and dependent variables. They don't change. X is independent, y is dependent. The difference now, a, b, and c are integers. Okay, so a, b, c are integers. Integers meaning counting numbers. Any negative or positive counting number, like -7, 8, 4, 3, 20, 100, -2,000. Numbers that don't work would be decimals, fractions, square roots, cube roots, anything like that. Only integers work. So a couple constrictions. A is a positive integer. So A is only numbers from 1 to infinity. Okay, and those are counting numbers from 1 to infinity. So 1, 2, 3, 4, those are all possible A values. B and C are just integers, so they're any whole number from -infinity to infinity. Just an idea of interval notation to show you what they could be. So, an example of standard form could be like 3x plus 7y equals -4. Must be positive, must be an integer. Must be an integer, must be an integer. These can be either negative or positive. So a couple of things. You can change this from slope-intercept form to standard form or standard form to slope-intercept. It doesn't work with point-slope form. Also, there are no fractions, no decimals, only integers. So, let's convert this to standard form. Ax plus by equals c. So we need this to be on the same side as this. So if we're given y equals -3x plus 1, how can we move the 3, or the -3x, over to this side? Well, let's do the inverse operation by adding 3x. If you feel more comfortable with the flowcharts, feel free to do it that way. 3x plus y equals 1. This is another example of a literal equation, just kind of moving numbers around, not getting rid of anything, just moving it around. And notice we're in standard form because a is a positive integer, and b, well, it's just 1, and so it's 1y, and c is 1. They're both integers. So everything's set here. No more issues. X and y are on the same side, everything is an integer. Y equals x minus 7. Let's convert it. So we want to move x on the same side, so we're going to subtract x. So negative, I'll put the numbers there just so you can understand the idea of the integers that we're talking about. -1x plus y equals -7. So it looks like we're in standard form until you remember a must be a positive integer, and this is negative. So the way we've gotten rid of negatives in the past is we multiply everything by -1. This gets rid of negative. Multiplying by a negative gets rid of a negative. So minus times a minus is a plus, right? Negative times a negative is a positive. So when we distribute this to everything, we would get x minus y equals 7. Now we're in standard form because that's a positive integer of 1, that's a positive integer, or that's an integer of -1, that's an integer of 7. So this one, when you look at these type of problems, you have to identify the issues. We know we have a fraction, so we're going to have to deal with that later. Let's add over the 1/4 x. So we have 1/4 x plus y equals 3. Now the only issue that's left is the 1/4. This is not negative out in front, so it doesn't need to change. but we need to get rid of the fraction. So how could we get rid of the 1/4 and make that into an integer? What could we do to change this problem from 1/4 to something that might work better for us? Let's try multiplying by the denominator. So we have a 4 that we're distributing to everything. 1/4 times 4 is 1, so we have 1x. 4 times 1 is 4, so 4y. 4 times 3 is 12. So now we have a positive integer, 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 and we're in standard form. So the next rule that I would state to you is when you have a fraction, multiply by the denominator. The denominator is 4, so I multiplied everything by 4. Remember, whenever I do to one part, I have to do to all parts, and that's why I did to everything. Let's try this one. Subtract the 1/2 x. So we see negative 1/2 x plus y equals 4. Well, now I have two problems. I have a negative out in front, and I have a fraction. So let's do one part at a time. The fraction tells me that I have to multiply by my denominator. The denominator is 2, so I'm definitely going to multiply by 2. How did I get rid of the negatives before? Well, I multiplied by a negative 1. So I wonder if I multiply by a negative 2, whether this would work. So negative 2 times negative 1/2 is 1, so 1x, which is good because it's a positive integer, minus 2y equals negative 8. And that seems to work well for everything. So in problems like this, you want to multiply by the greatest denominator, which in this case is 2. Sometimes you'll have two denominators, multiply by the greatest denominator, and if you ever have a negative, make that number negative. So here we have standard form again. One last little application is if we graph from standard form, the only way to do it is to find the x and y intercepts and plot them on a graph. So we have this equation in standard form. 4x plus 2y equals 12. To get our y-intercept, that's where we cross the y-axis, we set x equal to 0. The equation of the y-axis, as we know, is x equals 0. So it makes sense to plug in 0 for x. Okay, so 4 times 0 is 0. Just divide by 2 now, and y equals 6. So we have a coordinate, x equals 0, y equals 6. Let's try the same thing for the x-intercept, where we cross the x-axis. And the horizontal line that makes up the x-axis is the equation y equals 0. So of course we plug in y, or 0 for y. 4x plus 2 times 0 equals 12. 2 times 0 is 0, and divide by 4 what's left, and x is 3. We have another ordered pair. 3, 0, right? Because x is 3 and y is 0. You'll have a little more time to explore this in class tomorrow, but that being said, all you have to do is plug in, if you're doing the y-intercept, the opposite variable for 0, or the x-intercept, y is 0, and then create the coordinate using that number, or that letter equal to 0, and whatever the other variable is solved for. When you plot it on the graph, you plot your x-intercept, which is 3, your y-intercept, which is 6, and you just connect them. So graphing on a standard form is relatively easy, as long as you understand the concept of plugging in 0 for the opposite variable.